Before we get on to our next talk, I just want to thank our sponsor, Orca Security, the leading agentless cloud security platform that delivers complete unified cloud security across every layer of your multi-cloud estate, enabling organizations to prioritize risk and achieve compliance. With that, we'll get on to our next talk, Operationalizing GCP's Asset Inventory for Cloud Enlightenment, with Randy Hines and Jeffrey Zhang. Thank you.
Okay, thanks so much. All right, everyone. Like you mentioned, we're going to be talking today about some of the efforts that we undertook at our company, Neuro, to improve our visibility into our cloud operating environment. So today, with me, Jeffrey's on stage, and also our colleague, Keston, who couldn't be here today. I hope he's dialing in from home right now, but the three of us are mostly responsible for what you're going to see today. So a little bit of the agenda today. We're going to talk a little bit about our company, our specific challenge, and how we came to come up with a solution for our inventory challenge that we had, how it works, some scenarios for how you might be able to use it yourselves, and some similar solutions, and then also how you can download the code for yourself. So for those of you who haven't heard of Neuro, we're a relatively new company where we make autonomous vehicles that do consumer goods deliveries. So imagine like your Chipotle deliveries showing up at your house and one of these little bots right here. They're all powered by AI and made by some really clever engineers that are using our GCP cloud environment in pretty interesting ways. So for a small company, I would say we are about 1,000 people. We have a pretty large GCP environment that's conducting a lot of machine learning and a lot of rapid development, which makes it very challenging for security engineers like ourselves in order to find out what they're doing today and then try to secure it. So I love this quote. I'm going to start a talk on inventory with this. So Daniel Meisler, who has a great blog, I'd recommend subscribing to if you haven't already, but he said, asset management is arguably the most important component of a security program, but I know of virtually 0 companies that have a single person dedicated to it. I'm pretty sure this is because most people think that we fixed this like back in 2001 with like, Intermapper and some, some scripts in the spreadsheet, and nobody wants to revisit it and actually realize that we have no idea what's on our networks. But for us, this is something that kind of rings true. As of about a year ago, we were wondering, what is the current state of what's in our cloud? And it's hard to do. It's a hard problem, especially with a very dynamic cloud.
Thanks, Randy. So yeah, next we want to give a bit of an overview of our GCP inventory and sort of why it presents such a challenge. So to put some numbers to this, at the top you'll see that we have 9 million plus GCP resources, and then on the diagram on the right, that's actually a Sumo Logic output of all our create and modification log events. So you can see daily we're getting about 300,000 changes, and we're peaking at around 400,000. So this is all to say that this GCP environment is really dynamic. It's continuously changing, and so it presents a complex challenge to how can you monitor this all in real time. And so when we wanted to tackle this challenge, we're looking at some of the key inventory goals. And when we first started building this out, we were looking at just from a security perspective. So for example, incident response. But as we built it out and more teams started to use this, we found out that this is a common case that a lot of teams can leverage and empower their use cases as well. So I think a good term to describe this would be data democratization. And so here are just a couple of common cases that we saw other teams utilize asset inventory for. So for example, with IT, they can use it for resource planning and figure out how many systems they use. For billing, obviously saving costs is a primary motivator. And so for cost optimization, figuring out how much cloud spend we're using for a particular compute instance, for example. And then for cloud reliability engineering, understanding our data better, getting better data visibility. So for instance, looking at Arcade's clusters and what versions we're running across the organization. And so we have a video prepared for one of our slides here. Hopefully the audio goes through. We're going to be talking about sort of our life before asset inventory.
We didn't have cloud asset inventory. We used the console, and we clicked, and we clicked, and we clicked, until our fingers got raw and started to bleed. And we liked it. Some folks were too good for clicking. No, they used the command line. And they'd write for loops, and we'd loop over zones, and we'd loop over instances, and we'd loop over little bitty parts of the instances. And if the results were paged, we'd loop over the pages. And we liked it. And there were so many ways the scraping client would error. We'd build try-catch ladders that went on, and on, and on. And we liked it. And we built a special scraper for every service. And there were so many services. And we'd loop over the services. And we liked it. And then it finally worked. But only on your small test account. And then you try to use it against a really big organization and discover that it takes 2 days. And since checkpointing wasn't built in, you'd fail halfway through. And you'd have to start all over again. And we liked it. So then, you got the really bright idea. I'll parallelize it with cloud functions and pub subs, and it'll be faster than Carl Lewis. And then you hit API rate limits, and it dawned on you that you're an idiot, and you just built a very large DDoS machine against your cloud. And we liked it. We loved it.
Yes. So yeah, following what Keston said, life before asset inventory was rough. And so you're going to talk and jump right into, what is Google Cloud Asset Inventory? And so this is what we're going to be diving into. And so for Google Cloud Asset Inventory, for those of you who don't know it, it's a service that's provided natively, and it provides some really solid defaults. And so on the right, you can see a diagram of a few of the built-in graphic user interfaces that it provides. So you can see there's some charts here, there's some visualizations as to what your compute instance locations are. And the nice thing about it is that it provides you real-time insight into your metadata. And the benefit, as Keston mentioned, is that it's faster than those G-Cloud inventory commands. However, it didn't work for all our scenarios. And so what we're missing is customization. And so the built-in GUI didn't figure out all our test cases. And so we decided to go with GCP BigQuery exports. So here's just a sample of what that export may look like. So at the top, you'll see a data set, so GCP org assets enrichments. And then here are a few of the tables that we brought out here. And these will all contain information regarding your metadata. So at the top, we have our more broad, more general resource metadata. And then at the bottom, you have your more specific per asset type exports. And so we'll be going over some of the trade-offs between exporting at a per asset type level and then also at a more general level. And so this is an example of what that schema may look like. So you'll see that we have a few common cases. So your name, your asset type, and also within the resource, some of the data. And so this is part of the, I think, motivation for creating views. So we'll go on later to show this through our queries, but here we just have a resource.data field, and that'll typically contain a lot of just raw JSON, which is typically hard to walk through. So creating views to enrich those data types is very useful. So how did we build this all out? How did we automate this process? So starting at the top, we have a diagram of our serverless design for automating the cloud asset exports. So on the left, we have a cloud scheduler, and essentially this will do a daily trigger on our cloud function through a pub subtopic. And our cloud function will then do an export from our cloud asset inventory. And you notice that these are a few of the schemas that are supported. So starting with the IAM policy all the way down to your resources. And one of the cool options that asset inventory provides is that you can export on a per asset type. And the benefit here is that you get more granular details. So we saw earlier from the resource, we just had resource.data, which is not very useful. So doing the per asset type export really helps with getting more insight into the specific schema that you're interested in. But there's also an option to export on not per asset type. And the benefit there is that there are some assets that aren't supported when you do per asset type. So a good example would be K8's pods. If you just do the per asset type, you won't find that information there. So we do it on both a per asset type and not per asset type level to get the best of both worlds. And so after doing all that export, that goes into our BigQuery tables that you guys saw earlier, and we keep that partitioned for 14 days just so, if we want to look in the past a week and see what a snapshot of our asset inventory looked like last week, we could do that as well. And from the BigQuery table, we do a few enrichments. So we have our saved queries where we can do one-off queries that we find useful and we want to look back on. And we also have some saved views as well. And so these views are extremely useful when combined with our web interface that was built out that Randy's going to talk about more. But that's that bottom diagram over there with what we call Clarity. And essentially, the back end of Clarity is utilizing those views that are created with the above asset inventory export there.
Thanks, Jeffrey. Yeah, so as Jeffrey mentioned, there's a lot of data within the export that comes your way. So when you open up BigQuery, it's going to show up with about 250 tables worth of data in there, which is just pretty overwhelming until you start to look at the schema as you showed. BigQuery has nested data types, so you'll find like arrays within individual rows within here. So while the data is great, and Keston would say, and we liked it, there was still a lot more to be done with this because it's not intuitive for where you want to get your data. For example, this query on the right here is how you'd like list out all of your Cloud SQL instances. And I don't want to write that query every time that I go to find out what that is. So we focused our time on creating some customized views for the things that we want to get easy access to. So we've defined about 50 different views for things that we like to access. And the cool thing about it is that you can join in on other data types. Like we export out all of our billing information as well. So you can join your resources on your billing to find out, what it's costing you month to month. So it can be helpful in that manner. In addition to that, this is all coming from BigQuery. So I think our data set's somewhere around 50 gigabytes of asset inventory information, which is quite a lot. And although BigQuery is pretty fast and everything, these queries can take some time if you're joining them across multiple tables. So as Jeffrey showed here in the bottom slide here, on the bottom part of it, we have a function that runs through on a daily basis and converts our views into snapshots. So basically executes the view, saves it as a static table. So in that case, sometimes you can say the view may take like 8 gigabytes of processing on the back end. And it can compress it down to like 35K and save you a lot of time and a lot of BigQuery dollars as well. But views aren't awesome by themselves, so we built a web interface on top of it we call Clarity, or the Cloud Asset Repository and Inventory Tool for you. Just rolls off the tongue. So this basically sits on top of the views and presents the data in a user-friendly manner so that not only security can use it, but our billing team, IT, asset management, all those folks can use this without too much of a hassle. For me, the big deal was, as a security analyst, is pivoting on things. So any field that it has consistency within the application, you can click on and you can pivot to that view within something. So if it's a service account, then you can drill into the service account, find out where else that service account is being used, et cetera, et cetera. Also, the ability to pivot to external resources here is pretty big. So it has contextual aware menuization, I guess you'd say, so that if you're looking at a specific type of resource, it knows that you can actually pivot to external resources as well within one click. This for me is a personal pain within GCP, although I find the menus to be pretty good compared to AWS, which I can't navigate at all. It can still take me a good 4 or 5 clicks and refreshes in order to find, like, you get in to your Kubernetes page, then you go into your nodes, and then you go into your workloads and stuff. Here, it can determine if you're on a workload. You can actually just click the workload button, and it'll bring you right into that interface there, or for billing information, it'll bring you right into the billing information related to that row of information. We have it pivoted into our Sumo Logic instance for our SIM as well, so it'll pull up just the logs for that instance or that resource, right? So it's all meant to kind of streamline things as well. And one last one for us, we rely heavily on Terraform, so this can get us right into our GitHub repository to find out what Terraform caused this resource to be created, which is handy, especially when you're doing incident response or something like that. The last area here of clarity that is helpful is this the search button in the upper right, which searches through that resources data set that Jeffrey mentioned earlier. And this is kind of that catch-all, all resources within your GCP environment. So if you don't know, for example, here's the word Acorn, a keyword that I knew about. Somebody told me there was an issue with an Acorn system, right? And so I say, I have no idea what that project is or what that resource is. So I do a wildcard search across our entire resources table, and you can find out all of the resources within your GCP environment that have that keyword in it. So you can see, you know, there's a K8s deployment here. There's some IAM, a BigQuery table in here as well. So you get an idea of, you know, what this may be related to. And then when you click in each one of these, you can drill down to the details related to it as well. This is also really helpful for things like, has anybody ever had the problem if you get a cloud IP and you say, is this ours? You know, is it ours right now? Was it ours yesterday? This is a great way to search across everything, because instead of drilling into, you know, all the different places where it could be, you know, the searches them all at the same time. All right. So I'm going to run through just a couple of usage scenarios here for how we've been benefiting from using this over the last 6 months or so. So kind of to Keston's example earlier. So imagine we're trying to find out all of our control plane ACLs for our K8s instances. About a year ago, we would probably start with going into the console and clicking through each single project, navigating into the clusters, and then finding the ACLs within here. This would take me maybe about 35 minutes. We have quite a few projects within our environment. And then extracting out all this data here and putting it into a spreadsheet and trying to determine something with, it would take a long time, and I'd probably get it wrong. Number two, if it gets a little bit better, we can use the nested G-Cloud commands here like Keston was getting at earlier, go through each project, and within each project, list out each cluster. And then with each cluster, you can list out the actual ACLs for each one. Pipe it through JQ. For me, maybe this takes 5 minutes to actually run. It takes me maybe about 20 minutes to write this script. And I have an entire directory filled with scripts just like this, trying to solve little bespoke problems every time. And then you borrow one from, it's a mess, right? So then it gets better, the best, right here with actually using the BigQuery interface instead. So here you just go right to the SQL or the BigQuery table, and you just write a pretty simple BigQuery command, and you can actually pull out that data real easily right here. Better yet, if it's even in Clarity already in one of those views, you can just look in the web interface and then just select the data that you're looking for from within there.
Cool. So I want to cover another use case that some of you guys might have run into, and that's how identity is managed for your Kubernetes workloads. So, you know, this might come up during a security audit session, or, you know, just for knowledge purposes, because as security engineers, we're interested in identity, and you know, Kubernetes workloads are used across the organization. So, wanted to run through an example of how you might go about using asset inventory to identify the different use cases of identity for your Kubernetes workloads. So here below, I have a few examples that are actually just taken directly from Google's own articles. So they provide a few different ways you can authenticate to Google Cloud in your Kubernetes workloads. So starting off on the left, we have our, you know, probably most simple, most basic solution, which is using the default Compute Engine Service account, which is included for all those workloads. And so this is the MAS solution. We've heard a lot of talks earlier today talking about the over permissive permissions, especially when these are shared across your compute engines. So we can utilize asset inventory to identify those use cases. The second one that's highlighted here is Kubernetes secrets. So you can actually create your own service account key for a given service account and then include that inside your workload as well. So this one's better, but there are still a few issues with having to do manual revocations or rotations if a service account key is compromised. So that brings us to our ideal scenario, the one that is recommended, which is using workload identity. And essentially, you can have your Kubernetes service account impersonate the Google service accounts in this use case. So this is the one that we can help our developers recognize and utilize asset inventory to work towards migrating to this solution. And so this is a sample query of how you might go about looking for these workloads using your default compute engine service accounts. So wanted to highlight, I know it's a lot of like text here, just wanted to highlight, I guess the bottom line here. So here we're just looking for a regex matching. So all your default compute engine service accounts will have the same suffix here, ending in the compute developer gserviceaccount.com. So this will be the substring that we're matching. And then we're going to be looking at the specific field in the node pool service account. And so this is a good example where doing the per asset type export is useful because you don't have to, break down that whole resource.data JSON field. And then you can get clear fields that match up with the particular service account you're looking for in this case. And so the cool thing about this is you can also join this table if you have an interest in what are the bindings for a given service account. So maybe you have another table that has, for this service account, these are the permissions. Maybe it has admin permissions, and that way you can prioritize fixing these default service accounts based on which ones have the most permissions. And this is the next example with our service account keys. So on the right, this is a sample deployments YAML file. This one's also provided by Google itself. And essentially what is done in this authentication scheme is they'll take the Google application's credential environment variable and they'll automatically connect to the service account key specified here. So if we go to our query, you'll notice that for our regex query here, we're looking at the substring for our pod containers and then looking for that specific Google applications credentials substring here. And this is a good example where we don't necessarily have the per asset type and we have to go look into the resource.data instance itself. And then lastly, our golden standard with workload identity. So this one's a little tricky. There's some cases here that might trip up developers, specifically that to get workload identity enabled, you have to first enable it at the cluster level. And while this is a prerequisite, it doesn't imply that all the workloads that are within the cluster automatically get workload identity enabled right away. So you might have some cases where you need to restart that given workload. And it's difficult just from looking at the console or doing these gcloud commands, the relationship between the cluster and the node pool itself. And so what Google Cloud Asset Inventory does really well here is showing the relationship between the clusters and node pools, and that way you can help your developers identify which case they fall into. And so on the right here, you'll see we have a sample query here that looks into the given node pool and what workload metadata config mode it's using. So typically, if it does have workload identity enabled, it'll have GKE metadata. Otherwise, it'll be null if it's not enabled. And then we're doing a join statement on one of the views that we created. So at the bottom, we have a clusters view. And that way, by joining the two, we can see whether or not it's the cluster that needs workload identity enabled or the actual node pool.
All right, so I mentioned before that the code that we had written here for clarity, which includes the views and also the snapshotting function, is public right now on our public GitHub page, which URL up down there at the bottom. To be released is the web UI. I'm still working on that for the time being. Couldn't get it done for the conference, but feel free to download that. Let me know if you have any additional views that you find useful in there as well. It'd be great to share them with the community. I know Google has been interested in this as well, as they're kind of building out some of their asset inventory and trying to make it more useful for everybody else. With this came some challenges. So I'll go through a few of the ones that we recognize. So right now, this approach is not real time. We do a snapshot daily. For us, that seems to fit our scenario pretty well. If you needed more frequent than that, you could certainly do it like hourly. But if you wanted real time, you'd have to do something like using the G-Cloud asset service to pipe data to a pub sub to update something, and that would get you close to real time. Also, I believe the Security Command Center for GCP, the premium version of it, does real time if you want to pay the premium for that. This does create some challenges for like those high churn assets like Kubernetes, where things are just turning over so quickly. The BigQuery dataset has a lot of tables I mentioned. There are some inconsistencies, and it doesn't have all of the data, but it's still pretty good. I'd say it's a good 95% solution, and you just have to kind of work with it. And GCP is also really, Google is really interested in hearing improvements as well. They've been able to fix some stuff for us as well. BigQuery's arrays are awesome, but a challenge to work with. So those are those nested array types. Cross join on nests are kind of a pain, but they help with these sorts of things to turn one-to-many relationships back into one-to-one relationships. For us, this isn't an issue, but if you're exporting the entire resource database for your GCP infrastructure, and there are people who are going to be accessing like a web interface or something that shouldn't have access to all of that, that may be a bit of a privacy issue or just an OPSEC issue if you have that. But for us, we share a lot of the visibility across our entire org, so it's not that. I suppose you could export certain tables to different places and give a subset of information to just certain people, but by default, it's kind of all or nothing. And I mentioned before, we optimize our view queries by creating those snapshots, and that can be quite an improvement. So I realize not everybody uses GCP. So there are some other alternatives out there. I mentioned for GCP, there's Security Command Center. That's the out-of-the-box cloud asset inventory product that was in a screenshot we showed earlier. It is definitely very good, but may not get you to that last mile of answering those questions about workload identity or things like that. You really need to export the data to dig into it. AWS has the Resources Explorer, which is a free option that you can enable. It's not enabled by default. In my experience, it doesn't have all of the resources in there, but you'll find things like S3 and EC2 instances. If you really want the real deal, then you're going to want to export your AWS config to Athena and then do something similar like we did today. Azure has the Azure Resource Graph, which sits on top of the Azure Resource Manager, which uses its own unique query language that's kind of SQL-like, and that seems to be similar to Cloud Asset Inventory for GCP. CloudQuery.io is kind of like OS Query, and that it would be something that would work across multiple CSPs. That's what they aim to do. From the looks of it, they do kind of the for loop approach on the back end where they're iterating through resources and putting them into a database. So you may find some performance problems there, or some concerns. We haven't tried it out, but it looks promising. And then also there's plenty of COTS tools out there. One I'm familiar with is Armis. And the benefit of some of these tools is that they actually integrate in other data sources, like say your vulnerability data from like a vuln scanner and things like that. So it gives you additional context as well. So in summary, you can't protect what you don't know that you have. So inventory is kind of the fundamental part of security that we all need to do. It's not sexy, but it's necessary. And definitely, we've been using for loops for a while, and this is certainly a lot better. You can answer questions so much quicker. It's much less painful. You can get so much more information out of it if you leverage one of these tools that already exist in all the CSPs out there today. So yeah, with that, I think we have some extra time. So if anybody has questions, thank you.
Thank you. So anyone has questions? Great.
Hello. Thanks. It was a great presentation. We are big GCP users as well. I was just curious why you guys picked BigQuery as the backend as opposed to like using a spanner or something. That's one part of the question. And the second one is like also from security side, we wanted to enhance the schema that Google provides to add like ownership and vulnerabilities found and other stuff that is company specific for the asset inventory. So is that something that you guys tried out? Because in your diagram, I saw you were persisting the data for 14 days and then refreshing it, right? So I'm assuming there was no custom information. So how did you go about it? Thank you.
Yeah, so the data that's held in BigQuery is partitioned for 14 days, and then naturally it ages out after that period of time. You could certainly keep it for a longer period of time. And also you're able to join, if you have some common criteria with something else, for example, our billing data, then you could easily do a join across other data sets within there. As far as like next steps, I'd love to put like our vulnerability information within that particular data set and then be able to join that so you get that additional context within Clarity for us. And then as far as the BigQuery, I think that it was because it was native. It's one of the native features of the G-Cloud Asset Export was just right to BigQuery. It's just a command that's built into it. So I think that's why we did that. We have our company uses a lot of BigQuery. So
It's very expensive. That's the reason.
yeah, so I think our entire BigQuery, I think that we're spending about $50 a month on it right now. And a lot of it has to do with the snapshots that we're taking because we run one query every night that pulls the entire data set down and then stores it in a static table. And it's pretty small because we're not pulling out every attribute, but the data still exists in the raw backend data as it is right now. So thank you.
Do you have other questions? Okay.
Were there some bits of the war story about allies and other parts of the organization that also needed the asset inventory data? A lot of times this is coming out of FinOps or out of other kinds of operational security needs or working with the identity side of the IAM teams on who's in and how people are do the joiner, mover, leaver process. Or is Clarity kind of built for this purpose and justified on its own?
So I'm not, nobody has come to us and asked directly for the BigQuery data yet. The web UI has been enough for most folks. It's primarily our IT and CRE folks who want to answer these questions, and also the financial operations, the costing folks. But that seems to, kind of scratch the itch for right now. But it's nice to have the raw data back there for those who may need to access it.
I also had a question about the ephemeral resources. Like, how big of a deal is it that I'm assuming that you don't capture things that kind of get created and destroyed between your snapshots. Like, how big of a deal is that? And is there some way to maybe look for just Kubernetes pods on an hourly basis and then sort of your slower moving infrastructure on a more daily basis?
Yeah, for sure. So I think one of the features that Cloud Asset Inventory supports is feeds. So I think for, as you mentioned, like the more faster moving services, I think that could definitely be a possibility there. So targeted, resources, have that more real time, and then zoom in on that. And then, as you mentioned, for some like the slower moving ones, taking that daily snapshot and having it more queryable would be a good fit.
Given the time and resources, are there any improvements that you would like to make to the tool itself or the backend dataset?
I would say I'll let Randy talk about a bit of like the web interface. I would say for the backend data set, I would definitely add in like the more real time, as mentioned with the feed data. And I think also building out more of the saved queries and the views. So the resource.data like field that I showed earlier has a lot of data. There's a lot of like JSON that needs to be parsed out. So I think we definitely still have more work to do there to get more enriched like data sets. And I think that will definitely help improve the quality when we do those joins to have more accurate data. So I would say, yeah, from the backend side, parsing more and getting more valuable data from the resources.
Yeah, I know one thing we talked about at lunch also was having some additional context within the web UI within there so that you can tell some, for us, it would be, what is the resource? Right now we have what's the billing information. The next best thing would be how often are people using it? Is it being used? Is it something that we can turn off? Is it something that's overused? You know, GCP gives you some of these hints when you go into the console. It says you're underspent. You could save some money here, but I think we could do a better job with some of our own internal knowledge about how our apps work as well. And then also in the UI, it'd be nice to be able to compare changes over time. Right now, it's just a snapshot from yesterday that we focus on, but to see what's changed within a project over the last 14 days or beyond, that would be great.
All right. Any last questions? All right.
Thank you. I just wanted to know a little bit more on your integration with Terraform and how you guys are using that. It's a big pain point for us. I'm just wanting to pick your brain on that piece.
Well, I mean, so we use Terraform for the majority of our Google Cloud environment. But as far as with the tool, it's a very loose coupling right now. So we have a fairly consistent, basically directory structure for all of our projects in Terraform. So by knowing the project ID, we can map to a GitHub repo that has all the Terraform within it, and then it has a consistent naming structure for all the directories of the components within there. So our CRE team is fantastic. They've been a big help with this tool and also in keeping our Terraform very nice and neat. And that consistency is what makes it possible.
All right. Thank you, Randy and Jeffrey.